Thus far, all of our programming projects have been sequential in their structure. And we've primarily followed a pattern of getting input, performing some process on that input, and then displaying the output. It might be a simple calculator. We're getting two numbers from the user and performing a mathematical operation such as multiplication and displaying that output. What we want to do now is add in another type of structure, which is a decision structure. And here we're asking some question or evaluating some condition, and we have two different branches that our program can take. If the condition is true, we're going to perform process A. If it's false, we're going to skip that process and just go on to the normal process that is performed. This is the very basic decision structure, which as we go through this lesson, you'll see there are other types of structures that are a little more complex than this. If we were to code this particular structure, we would use an if structure in which we have the keyword if, some Boolean condition or Boolean expression that is being evaluated inside the parentheses, and then inside the brackets would be what we want to have execute if the expression is true. For example, we might be asking as the user enters a password if that password matches what we're expecting. And that's what is here inside the parentheses of password underscore txt.text equals, notice there's two equal signs there, and I'll explain that in a minute, the password. And the password would be a variable or maybe even a constant that contains some value that we're comparing to whatever they entered in the text box. If those match, we would place in the feedback text the word welcome. We might also have an additional fork in an if structure, and now it's called an if-else. So if the condition is true, we're going to do one thing, but if the condition is false, falling under the else, we're going to do something completely different. And you can see in the flowchart there, we now have two different forks that we can go down, and we're only going to do one or the other. So we're either going to perform process A or we're going to perform process B. We cannot perform both. So going back to our password example, if it's true, again, we're going to put welcome in the feedback, but if it's false, we're going to tell them to try again. And then we can make this if structure a little more complex in that we can have multiple forks. And here we're looking at one condition, condition 1, and if that's true, we're going to perform process A. If it's false, we're going to evaluate a second condition, and if that's true, we're going to perform process B. And if neither of those conditions are true, we're going to do the else fork, which is the default value, and perform the default process. So an example of this might be we're looking at the system clock, and let's say we put the current clock or the system clock into a variable called current time. And then I have a constant called noon, and I'm going to compare the current time to noon. And if current time is less than noon, we're going to put in feedback text box, good morning. And if that's true, we're going to skip everything else in that clause. If that's not true, then we're going to look at the else if and compare the current time to our constant called 6 p.m. And so if it's less than 6 p.m., we're going to tell them good afternoon. And if the else if is not true, if it's not less than 6 p.m., we're going to assume it's 6 p.m. or later, and we're going to display good evening. We can have as many else if clauses as we would like. So here's another example. Here I've got 3. The first condition is we're asking if it's raining. If it is, we're going to tell the user to take their umbrella. If it's not raining, we're going to check to see if it's windy. And if it's windy, we're going to tell them to take their comb or hairbrush. If it's not raining or windy, we're going to check to see if it's snowing. And if it's snowing, we're going to tell them to take their coat and gloves. Else, our default process here is going to be, it must be sunny out then, and we'll tell them to take their sunglasses. If we were to follow the flow of our flowchart, notice that if the first condition is true, we do process A, and then we come and we bypass all the other processes. If that's false, and we do come down to condition 2, and that's true, we're going to do process B, and then we're going to bypass process C in the default. If that is false, we're checking to see if condition 3 is true. If it is, we do process C, and we bypass the default process. And if none of those are true, we're doing the default process. So only one of those 4 processes are going to be executed. We could actually have 20, 30 different processes here if we wanted, with multiple else-if forks. Now here's an alternative, and this is called sequential if structures. We have multiple if conditions, but they're not bypassing each other. So it's going to test for condition 1 and then perform process A or not perform it. It's going to test for condition 2 regardless of whether condition 1 was true or false. So if you notice the flow line there, it's coming in after perform process A. Both forks are coming back before we get to condition 2. So in this manner, we would actually be testing multiple things and possibly providing multiple feedback. So if we were concerned that it might be windy and rainy, we might want to tell them to take their umbrella and take their comb or hairbrush. If it's windy and sunny, we still might want them to take their comb or hairbrush, but also take their sunglasses. So by doing sequential if structures, we can allow code to execute multiple different forks without bypassing the others if one of them is true. Whether you use an if, else-if structure or using a sequential if structure is really dependent on what you want to accomplish. Another type of if structure is called a nested if structure, in which we have a second if structure inside one of the forks of the first if structure. So in this case, we have a condition 1, and if that is true, we're going to do something. But if it's not, in the else clause, we're going to do something else, and then we're going to look at another condition and either do something there if condition 2 is true, or something else if condition 2 is false. We in essence have 3 forks here. If condition 1 is true, that's one fork. But if condition 1 is false and condition 2 is true, that's a second fork. And then the final fork is condition 1 is false and condition 2 is true. When we have multiple forks that we only want to have one condition tested in, we might use a switch structure. So switch is looking at some value to be examined and then it's comparing it to multiple possible values. And on any one of those matches, or the first match it comes across, it will do that process. In this switch structure, only one process is going to be performed. And we code this a little bit differently. We're using the switch statement with the container. This is just a variable. It could be the text of a text box, but some type of container that we're looking at the value of it. And then inside the brackets, we have multiple cases that are simple values. So if the container was value 1, we would do something if that was a match. And notice there's a break statement after or inside each of those cases. That means basically ignore the rest of the cases. So if case value 1 did not match, well then we're going to compare to value 2. And if that matches, we'll do something. If that doesn't match, we'll compare value 3 and so forth until we get to value n, which might be a 4th value, it might be a 100th value. And if none of those are true, we might also have a default case that we would do something if there were no matches whatsoever. Now let's talk about the conditions. Those conditions that we saw inside the parentheses for either the if or the if-else or if-else-if are called Boolean expressions. It is some expression that can be evaluated to true or false. 1 plus 1 equals 2. Now notice the double equal sign. That is the Boolean operator for is equal to. So 1 plus 1 is equal to 2. That is a true statement. But 1 plus 1 is equal to 3 is a false statement. So the conditions can be evaluated either true or false. 7 is greater than 2, that's true. 7 is less than 2, that's false. 4 plus 1 is greater than or equal to 5. So we have a combined operator there of greater than or equals. 4 plus 1 is greater than or equal to 5. And as long as the left is either 5, 6, 7, or anything higher than that, that's going to be a true statement. But in the next one, 4 plus 1 is less than or equal to 3. Well, that's a false statement. 4 plus 1 is greater than 3. And then the final one, the exclamation mark equals, means is not equal to. 4 plus 1 is not equal to 3. That is a true statement. Now, rather than numbers, we're usually using variables or some type of container on one or both sides of the condition. So we might be asking, is the value that's currently contained in x equal to the value that's currently contained in y? And you see the ActionScript statement there of x is equal to y. That might be true, it might be false. Then we might say, is x greater than y? And you see the Boolean operator there for greater than, and the Boolean operator for the opposite, which is less than. And then we have these combined operators, greater than or equal to, and less than or equal to, and then finally not equal to. Now we might have, is x equal to 5? So it might be a container on one side and a literal value on the other side, on the right hand side. In each case, whether the condition is true or false will determine which fork of an if-else structure we execute.